Welcome back. I hope after that refreshing break, we're all energized for the last session of the day. And that is on the changing industrial landscape with innovative gasification technologies. Now, earlier in the day, we've heard from the BHEL spokesperson, and BHEL has actually developed the fluidized bed gasification technology suitable for high ash Indian coal to produce syngas and then convert the syngas to methanol with 99% purity in their pilot project in Hyderabad. Of course, we will wait to see if we can replicate the success on scale as well. Now, integrated coal gasification combined cycle power plants, coal beneficiation, pulverized coal combustion, fluidized combustion, and carbon capture and storage are some of the technologies which may be suitable and relevant to India. Now, this session will showcase the state of the art technologies and innovation in the field of gasification from technology leaders who will be speaking very soon. To all participants watching, please put in your questions as soon as it comes to your mind. Please don't wait till the end of the session. We may miss out on some of the questions if they come too late. So, any question that you get in your mind once you're hearing a speaker, just put it in the Q&A section. Also, raise your hand and you can ask your question directly on the stage to the speaker to whom you want to ask the question. So please welcome our speakers who will be giving us their presentations. We have Mr. Rahul George, Country Head, Case Group, Mr. Varun Kumar, Managing Director, Dev Energy, and Dr. Prakash D. Javan, Senior Principal Scientist at CSIR CIMFR. A warm welcome to all of you gentlemen, and thank you so much for joining us. I request Mr. George to please start and talk to us about the innovative technologies in gasification that are being used today.
Thank you, Nisha ji, for a wonderful introduction. A very good evening to my fellow speakers and the entire audience present here. It's a pleasure to be part of probably the only platform in India for coal gasification. And since the conception of this summit, CASE has always been an active participant of this prestigious annual event. I'll just open up my slide. Okay, can you see my slide here?
Yes, Mr. George, we can see your screen. We can hear you clearly. You can go full screen and start.
Okay, the topic of my paper is coal gasification utilizing India's huge energy reserves. As we all are aware of the fact that India possesses an enormous reserve of energy in the form of coal, which amounts to almost 300 billion tons. The challenge is how to utilize this humongous energy source within a time frame before we become a carbon neutral country. Our Honourable Prime Minister at COP26 summit in Glasgow, Scotland, has set a target to make India a carbon neutral country by 2070. An immediate commitment of 500 gigawatt power generation through non fossil energy target for 2030. These are very optimistic and can be achieved if the right direction is taken. Under the present condition and set timelines, coal gasification is poised at an extremely positive threshold as it can play a very vital role in substituting the use of high cost fuels such as furnace oil, natural gas, LDO, etc., which are being used as industrial fuels. The right coal gasification technology will not only be able to utilize India's huge coal reserves in an environmentally friendly manner, but will also assist in bridging the gap of our balance of payments by lowering our energy dependency on oil and gas imports. So, in every way, coal gasification may be considered as the only way forward to utilize our coal deposits quickly, efficiently, and in an effective manner. A quick recap about who we are, what we are, and where we are. Under the leadership of our managing director, Mr. Roger Kumar, CASE set its footprint in the industry in the year 1993 with its head office at New Delhi and works at Bahadurgarh, Haryana. Initial setup was to manufacture industrial cooling towers and non-chemical water treatment equipment called scale ban, which is a revolutionary product used for preventing deposition of hard water scale in heat exchangers. Both our products got a very good response from the steel industry, which got us closer to the steel industry in particular. And that is how we got associated with the steel industry in a major way. Then in 2000, in the year 2000, number of steel melting shops were in need of air pollution control equipments. So we ventured into the field by setting up bag filters, cyclone separators, scrubbers, etc. In year 2007, Case entered coal gasification business with the hot gas technology in partnership with a Chinese company, Keyon. Fuel prices were skyrocketing at that time, and coal gas turned out to be the cheapest and most economical way of heating billets and blooms for steel rolling mills. We are proud to inform you that since 2007, Case has successfully installed more than 300 gasifier projects for such applications. Hot gas technology had limitations of burner level automation, distance constraint for gas transportation, and pressure related issues. So, in order to overcome these challenges, in the year 2013, Case introduced pyrolysis coal clean gasifiers for special applications like automatic rolling mills, iron ore pellet plants, glass plants, etc. With development in gasification technologies, Case in the year 2019 partnered with KEDA Group China to introduce circulating fluidized bed and entrained gasification. We will be discussing all these technology features in the upcoming slides. With all these technologies and expertise in gasification, Case is in talks with American companies to introduce plasma gasification and give this technology to India. At this point, it is very important to have a glimpse at the coal gasification value chain. Apart from the basic use of coal gas as a thermal fuel, post generation and reforming of gas, coal gas can be converted to liquid fuels like diesel, naphtha, gasoline, etc. Synthetic natural gas can also be produced through gasification route. Producing fertilizers is an important and effective means of utilizing coal gas. In steel, coal gas can be used for DRI making, and with the desired heat values can also be used for power generation. So from this slide, we can study the vast use of coal gas it can have and it offers for the industrial applications. Now here I would like to run through the various coal gasification technologies which Case is offering, point-wise understand the technology features and the applicability of them from an industrial usage point of view. Our first variant of coal gasifier is the single-stage hot gas station. This is an updraft fixed bed gasifier, and hence it is designed to gasify sized or lump coal. Optimum size of coal is 20 to 60 mm. For this gasifier, air and steam as gasifying agents are blown into the gasifier from the bottom of the gasifier. The gasifying agents pass through a bed of coal inside the gasifier shell. Oxidation and reduction reactions take place at different stages of gasification process, and coal gas is generated which flows from gasifier top. The gas is then transported through gas pipelines to utility point where it is combusted and used as a fuel for the plant's thermal demands. The most important technological feature of this gasifier is that the gas exits the gasifier at temperatures over and above 450 degrees. Thus, it is called a hot gas station. Because of this feature, all the volatiles and condensates present in the gas remain in gaseous form and become an integral part of the gas and combust at the burner point. Because of this feature, this is a zero liquid discharge technology. There is zero tar and zero phenol water which comes out of the gasification process. This is because the gas temperatures are always kept over and above the condensing temperatures of tar and condensates. Depending on the quality of coal, these gasifiers can generate gas up to 12,000 normal meter cube per hour in single cell. These gasifiers can be designed to offer a wide range of gas outputs, varying from the smallest 1,000 normal meter cube per hour to 12,000 meter cube per hour in single cells. Gas calorific values from these gasifiers can reach up to 1,800 kilocalories per normal meter cube. This is because of the volatiles present in the gas in gaseous form. To sum up, the gas thermal value for these gasifiers is a summation of gas composition plus gas volatiles plus the gas sensible heat at 450 degrees. These gasifiers are hot selling cake for the secondary steel plants for rolling mill applications, strip mills, and refractory making. Our second variant is the coal pyrolysis gasifier. As explained in my previous slide, hot gas technology had a few limitations, such as burner level automation was not possible, limitation in gas transportation, the gasifier and gas usage point had to be close to each other, distance to be maintained between within 75 meters. Gas cleanliness could not be used for peculiar application where the product quality could be hampered by the impurities present in the gas. Gas pressures could not be boosted, maximum gas pressure achievable in this case was 100 to 150 mm water column. In order to overcome the above four limitations, Case manufactures pyrolysis coal clean gas station. Just like the hot gas station, the pyrolysis coal clean gas station is also a fixed bed gasifier, and size coal of 20 to 60 mm can be gasified through this gasifier. This is almost double in height as compared to the hot gas station. Air and steam as gasifying agents are introduced into the gasifier from the bottom. They pass through the oxidizing and reducing layers within the gasifier, and coal gas is generated. In this design, we have an added zone called the pyrolysis zone. In this zone, up to 90% of the coal volatiles are cracked into high calorific gaseous hydrocarbons, termed CNHM, which become an integral part of the coal gas. These hydrocarbons account for the higher calorific value of coal gas from these gasifiers. The gas flows from the top of the gasifier and is made to pass through a series of gas purifying equipments which extract all the gas impurities, thus making the gas clean. A gas boosting station can boost the gas as per the requirement of the burner combustion systems. Temperature of this gas at the exit of gas boosting station is kept below 45 degrees centigrade. This is done by passing the gas through an indirect water-cooled heat exchanger. At no point throughout the gasification purification process, water is made to come in direct contact with the gas. This is also a zero liquid discharge technology, like the hot gas technology. Gas condensates and phenols are treated and recycled back into the gasification process. Tar generated in the process is collected in underground concrete tanks and is used as fuel for the plant's thermal energy requirements. There is no disposal of any liquid in this technology. Just like the hot gas technology, the pyrolysis clean gas is also capable and designed to offer a wide range of gas outputs, varying from smallest 1000 normal meter cube to 12,000 normal meter cube in a single cell. A wide range of coals can be gasified through this technology. These gasifiers have been tested to run successfully on coals having ash content up to 50%. As the gas temperatures are ambient around 45 degrees and the cleanliness of the gas is high, burner level automation becomes possible for these gasifiers. We have tested the gas from these gasifiers for extremely peculiar applications like porcelain insulators, glass plants, aluminium plants, etc. As explained earlier, these gasifiers are designed to convert coal volatiles in hydrocarbons. These hydrocarbons increase the overall calorific value of gas. We have seen that these gasifiers are capable to give gas calorific values over and above 1400 kcal per Nm3. This variant has a wide applicability. Major plants are automatic rolling mills, glass plants, pellet plants, aluminium plants, etc. A third variant is the circulating fluidized bed coal gasifier. We have partnered with Keda Group, who are the pioneers of this technology, and have successfully set up more than 100 such plants worldwide. Our main objective to incorporate the fluidized gasification technology was to overcome the challenge of availability of sized coal. For fixed bed gasification technology, lump coal is gasified. This calls for setting up a coal processing system, and the fines generated during the process of sizing were of no use to the end user. CFBC technology utilizes such coal fines and bypasses the entire process of coal preparation. A simple schematics can be set up for this technology. This technology gasifies coal fines of size less than 10 mm. Final gas temperatures after gas boosting station are kept well below 45 degrees centigrade for convenient gas transportation and usage of gas with the highest automation level. Unlike the fixed bed technology or hot gas and pyrolysis gasifiers in gasification process, through the CFBC gasifiers, there is zero generation of these hazardous substances. Thus, this technology may be termed as a zero liquid generation technology in comparison to zero liquid discharge technology. Gas calorific Gas calorific values with air as gasifying agents can reach up to 1300 kcal per nm cube. In case higher gas calorific values are required, then oxygen enrichment is also available with this technology. Reduction in nitrogen in final gas results in higher gas calorific values. Plants with gas CV of 1650 kcal per nm cube are running successfully worldwide. Depending on the project commercial viability, the smallest capacity for these gasifiers is 10,000 normal meter cube, and the largest is 60,000 normal meter cube per hour in a single cell. Because of its size dynamics, these gasifiers are suitable for large plants where the plant thermal demands are relatively higher, such as aluminium calciners, iron ore pellet plants, specifically straight grade technology, integrated steel plants, and so on and so forth. A fourth variant is the entrained gasifier. One of the major limitations of CFBC gasifier is that it is capable to gasify low ash coals having ash content below 20%. This is a very big challenge for a country like India, which has abundant coal having high ash content. Thus, a need to have a technology which could successfully gasify the high ash coal was much needed. For this reason, CASE introduced the Entrained Gasification Technology in partnership with CADA, a CFBC gasification partners. In this technology, the coal is pulverized to size below 100 micron and fed into the gasifier from the top along with steam and oxygen. This is a downdraft gasifier. 99.99% oxygen can be used as gasifying agents in this technology, thus reducing the nitrogen levels in the final gas. Like the CFBC technology, the entrained gasifier is also a zero liquid generation process. All the coal volatiles are combusted within the gasifier, thus the gas generated is devoid of any tar and phenolic water. These gasifiers also come in bigger capacities, varying from 10,000 normal meter cube to 80,000 normal meter cube per hour gas flows. The absence of nitrogen in the final gas helps the gas calorific values to reach up to 2,500 kilocalories per normal meter cube. Low ash coal fines can be gasified, thus making this the most efficient gasification process available today for India. This is an interesting slide which we have prepared, where we are going to show you the energy cost with respect to the various gasification technologies available in comparison to the high cost fuels that are there available in the industry. So this shows the cost per million kilocalories for different gasifiers. The hot gasifier cost for million kilocalories is 2050. For pyrolysis is 2140. For circulating fluidized bed gasifier, it's 1980. Entrained gasifier, it is 1680. So we can clearly see that the entrained gasifier is the most efficient economically. Depending on the capex and project viability, these gasifiers can be promoted in India in a very big way. Now we've compared the energy cost of different fuels being used in the industry for thermal applications. Here we have taken HFO, heavy fuel oil. The cost for that for 1 million kilocalorie is roughly around 5,000 rupees per million kilocalorie. For PNG, it's 5390. For LNG, it's 6936 rupees per million kilocalorie. So we can clearly see that gasification is the ultimate source of a cheaper energy, a cheaper fuel by almost 40 to 60%. Uh, this sums up my presentation. If you have any questions, do let me know.
Thank you so much, Mr. George, for your presentation. Again, request to all the participants. You've heard Mr. George. In case you have any questions, do keep them ready. You can even type them into the Q&A box. At this point of time, I request our next speaker, Mr. Varun Kumar, the Managing Director of Dev Energy, to give his presentation. And, you know, towards the end of the session, we try to take up the questions. So thank you so much for your presentation, Mr. George. And Mr. Varun Kumar, over to you.
Yeah. Good evening, everybody. First, I'd like to thank Mission Energy and Achinji for relentlessly keep organizing these events, which have become the only platform for our industry, gasification industry. And then I'd like to thank Rahul, for summing up so nicely what we have been, both of us, KS and Dev Energy have been doing, and and we have been, I think, probably good marathon runners, pushing each other, over last 14, 15 years to be active. And this innovation world has been part of both our organizations, DNA. Keep finding new things, keep doing new things, keep challenging people. That's what we have been doing. And one bottom line before I start my presentation, I'd like to say is that when, like Dr. Saab, I was talking backstage, when there was no innovation in India on gasification, we have been trying to get the same from China. The Chinese have been 20 years ahead of us on this. We have similar amount of coal, we have similar energy needs, but we have been way behind in using coal for our energy needs. And now that government has started pushing, and which all the speakers have been since morning saying, so we are very happy. But since 2004, when we started till now, it's always been a fight to convert what is available in China into what is Indian circumstances. And that's what has been the DNA of innovation which we have been doing. So I'll just switch on my slides. Are the slides visible?
Yes, we can see your slides and we can hear you loud and clear. Please go ahead.
Yeah. So just a brief background of who we are. Uh, we have been working in the area of coal gasification as a technology EPC provider since 2004. And we have right now around 180 operating gasifier systems. All of them are fixed bed, air fed, and normal pressure. So why these 3 points are important is because when you have a gasifier which is at normal pressure, the capex of that equipment is very nominal. Then second point, when it is air fed, not oxygen fed, the whole combustion mechanisms and the dynamics within the gasifier are really controllable, and therefore the capex and refractories and the steel and the cooling mechanism, everything is at normal operatable pressures and quality. So therefore the capex for these plants have been very reasonable. And as Rahul had presented, that when you have a saving of 40% in a fuel, and for a rolling mill, typically if you are consuming a 5 crore rupees of fuel in a year, and a 40% saving gives them a 2.5 crore saving, then the capex has to be in that range to make it a logical investment. So most of the plants which we have done in India, the payback has been less than a year. Most of these plants have been in steel, ceramic, glass, and non-ferrous industry, and in partnership with our partners in China, Yishin. Now, the key to innovation is, there are two parts to innovation. Part one is that I bring something to the table, a technology, a solution. But there is another part, which Mr. V.R. Sharma was saying in every subsequent line, is the entrepreneur's role. The entrepreneur has to take the call to buy that technology, to take that risk, to invest. If they don't do it, then none of these first plants will come. Because once the first plant has come and the technology is proven, then the second is very easy, right? So today, why are we fighting with the indigenous technology development in the area of methanol, or even for converting the rice straw, which Mr. Sharma was saying, into anything usable for boilers? Is because nobody's ready to put the first plant. So what we have tried to achieve from last uh, 15, 17 years we have been in this business is to come up with solutions and go to customers, go to willing clients, and present these solutions in form of doable risk-free ventures. And therefore we have been able to achieve first coal gas plant in iron ore pellet, first uh, coal gas plant in glass furnace, bone china. So many such firsts we have tried to achieve in the last decade. So what is the core of the technology? The core of our technology is that it's a two-stage fixed bed updraft technology, wherein you treat the coal in two parts. So why two parts? Because the energy of coal is locked in two components. One is the volatile matter, which are the hydrocarbons. The hydrocarbons lock their energy in form of unsaturated double, triple bonds hydrocarbons, which need to be taken out at a lower temperature if you want to avoid cracking and you want to take out their higher energy. So that is step one. And step two, then you need to convert the carbon into the gases of gasification, which are a combination of methane, carbon monoxide, and hydrogen through the reduction and gasification reactions. So what we do, our gasifier convert the coal in these two steps into two gas trains, one upstage, one downstage, with two different characteristics, which through this complete cooling and cleaning process, six stages, different stages of cleaning and cooling processes, we take out all the tar, dust, and we cool the gas to ambient temperature, like 45 degrees, and then we boost it, take the sulfur out, and make the gas usable for any industry. So the gas at this stage becomes clean enough to replace propane, natural gas. It becomes clean enough to be compressed and to be transported over large distances. We have a plant where we are running it over 200, 2.5 kilometers. Then in terms of cleanliness, we have a plant where we are running this gas on a bone china kiln, where the particulate matter, the tar and dust, is required to be less than 10. So uh, the gas outlet quality can be tailored to the customer requirement for all the thermal applications almost under the sun. Our Chinese partner have more than 45 industry experience. I in India have done around 8 different industries where these gasifiers are operating 100% successfully. Most of these systems are completely automated and synced with the user. So the furnace DCS automation system and the gasifier DCS automation system are synced, and both of them run parallelly and in sync with each other. So therefore, currently the systems are 100% reliable. They have an uptime of almost 1.5 years without shutdown. The reliability is such that most of our clients today do not have even backup fuel. So they have independent gasifiers. They don't even have any other fuel line in the system. So that is the level of reliability and comfort we have. So these are some of the projects descriptions which we have done. These are pellet plants, straight gate pellet plants. This is a glass unit we converted from the conventional fuel to coal gas. This is Jindal Steel and Power. Their Patratu, they have a rolling mill which has a 260 ton per hour furnace which is running on gasifier. Uh, these are some of the ceramic tile units which are running on our gasifiers. So in ceramic tile, the temperature required in the kiln has to be maintained at plus minus 1 degree in every zone. So therefore, the system which you supply to these plants should be responsive enough to change its flow based on that modulation of the furnace for 1 degree. So therefore, these are very robust and reliable system for heat application. Now, I like to, at this stage, I'll carry on from where Rahul has left. That why, I mean, we have been successful. We have been doing so much business for last, 15 years. But still, what is the road ahead? What are the current challenges with these technologies? So, challenge one, they can use only sized coal. So, 15 to 70 which was readily available when the overall demand was less, and you could use the residual finer coals in DRI sponge kilns and the power plants. But currently the dynamics of coal have changed, and the sized coal prices, if you want to size it, the prices are very high, and if you want to put a very large systems, then the amount of sized which you recover is very less. Second, because they have a large fixed bed, you need a particular hardness and you need a very high ash fusion temperature for these coals, for these gasifiers which can be used in these coals. And then one module can generate, 10,000, around 10,000, 8 to 12,000 maximum gasifier NMQ per hour per gasifier. So if somebody wants, let's say, 200,000 nm cube of gas, so then you need to put up 25 systems, 20 plus 4 standby, which becomes a really sort of illogical setup. The carbon conversion is low. Both tar plus gas, the conversion maximum we have reached is 89%. But still, I mean, we are saying it's the best in the world, but still, as compared to the other technology platforms, this becomes 10% lower, right? So you are at 96% in CFD gasifiers. Because of nitrogen, there is a carryover when you are taking the gas, because 52% of nitrogen goes from the gasifier through the furnaces. So in case there are furnaces where they don't have the volume to take that nitrogen, then the gas calorific value has to be higher, nitrogen should not be there. So what is the solution? The solution moving forward is circulating fluidized bed. So what is a CFD gasifier? A CFD gasifier is basically a large diameter, a large height chamber where you are injecting pulverized coal, and the high pressure charge is making it float. And in the flotation process, all the carbon content in the coal is getting converted into CO and H2 if you are using water, and that gas combination is then taken out through a basic cleaning and cooling mechanism through waste heat boiler, then cyclones, bag filter, indirect cooler, to make it into a usable gas which can be used for thermal application. Now, when you take this technology and operate it at normal pressure, atmospheric pressure, you're not operating it at very high pressures like 10 bar or 20 bar, which our European gasifier technology license providers are doing, then yes, the rate of reaction is low, but the cost of equipment, the capex, is very low also. Second, when you are using air as the charge, then the reaction temperatures are very low. Therefore, the refractory lining inside the gasifiers are normal, and the whole system operates at a very large range of flexibility. You don't need to operate the gasifier at a very tight range. So therefore, this becomes a very doable solution. In China, our partners have supplied at three places where alumina calciners are running on gas generated from these type of gasifiers, complete thermal application, air-fed gasifiers, and they have replaced 100% furnace oil. In India, all the calciners today, all the major brands, Hindalco, Vedanta, everybody is running calciners on furnace oil, and it's a huge, it's a large consumer. The amounts are enormous. Amounts of furnace oil they are using are enormous. Even pellet plants, the large pellet plants, the 4 million ton, 6 million ton pellet plants are running on furnace oil. So this is the ideal solution for them. This is one of the photographs I've just put in to show what type of setup this runs. So this is the main body of the gasifier, and then the heat exchanger and indirect cooler. So this is the train. So why is CFB the future? One, it can use coal fines. Second, it's an open source technology. There is no license fee. What is famous about China is that there is no charge for drawing, right? So when you do business with China, it's the charge only for the equipment. So once a technology has been tried and tested in China, then the equipment is available without any exorbitant premiums over the cost of construction of the equipment. It is atmospheric pressure, I've already explained. Now, because your operating temperature are medium, so therefore the possibility of clinkering of ash, possibility of fusion of ash is not there. Then medium level of gas cleaning, you don't need the large rectisol and other types of gas cleaning systems, which are even more expensive than the gasifier train. So you are using the basic rudimentary systems to clean the gas. The single gasifier is available up to 40,000, 60,000 meter cube. Also, a new model has come up 8 meter. So therefore, if there is a large user, then three modules can supply them the required gas. And the capex per gasifier is much lower than any competing technologies for such thermal applications. Now, before I go to this slide, I'd like to add one point here, which was presented by Rahul, that yes, CFD gasifiers, there is an issue with high ash. Now, my understanding of last 18 years in this business, high ash has problem in all the gasifiers. So rather than fighting with the problem, I have a more practical solution. You see, lignite and Indonesian coal, high VM, low fusion temperature, high moisture coal is readily available at a comfortable cost. If you are blending these two coals, then you get a coal which is absolutely desirable for these gasifiers. The high ash coal is a problem in any type of gasifier. Why? Because in the fixed bed, it will create clinkering. In the CFB gasifier, it will not float because of its density and its tendency to fall. And its entrail bed, it will create blockages in the entrailment of the flow. So in any case, it is a problem. Unless somebody puts a gun to my head and says you have to put this gasifier, I'll not use that high ash. I'll rather come up with a solution of blending. And most intelligent operators across the world have been using coal blending as the right solution to gasification problems. Most of that data is not in public domain, because even for JSPL, the blending techniques and the systems they have used, there are many people in the audience who have been operating those plants. I don't know whether they'll share it or not, but blending is the solution, right, for all types of gasifier, fixed bed, CFD, entrail bed, all types of gasifier. One last final slide of innovation, which I have an idea. I have been trying to work this out with the stakeholders, both from the DRI clean side and the gasifier side, and it's a work in progress. So I just wanted to throw it open to the audience and the team so that industry can pick it up and maybe we can come up with some solution. So the idea is that you have a CFB gasifier or any type of gasifier wherein we use coal and generate a gas. Now this gas, if generated at normal pressure and under normal gasifiers, will have low hydrogen and more CO. Now the DRI kiln, the vertical kiln, needs more hydrogen. So the idea is to compensate that through green hydrogen or gray hydrogen through a thermal power plant or a solar plant feeding a PEM hydrogen generator, and you take a hydrogen and then you combine them to create a gas strain and a ratio which is suitable for the feed of the DRI kiln. So therefore, in this system, you are only putting coal for thermal energy for power plant, and you are putting coal, and the oxygen generated through the PEM generators can also be used as a feedstock for the gasifier. And the hot DRI can be fed into EF, which is already happening in the JSPL Angul plant and also in JSW Pen plant. So, and this can be used to generate steel. This whole process will take us away from met coke blast furnace route and will help us in this journey to self-reliant coal-based steel production. So that's my final submission of idea. Thank you. Thank you.
Thank you, Mr. Varun Kumar, for your presentation. And we are getting some questions as well. My suggestion is that at the end of this session, we can request some of the speakers who have questions to come on stage and ask their questions. I think Mr. Tiwari is keen to ask questions. Mr. Tiwari, I request you to hold on because we have one more speaker. And once you've heard him, we will start this discussion. So please welcome Dr. Prakash T. Chavan, Senior Principal Scientist, CSIR, CIMFR, and he's ready to give us his presentation. Mr. Kumar, you'll have to stop your sharing so that I can then invite Dr. Chavan to start with his presentation.
Already done.
Yeah. Is it visible, madam?
Yes, sir. We can see. Please go ahead.
Yeah, namaskar. Myself Prakash Chavan from Central Institute of Mining and Fuel Research. Today, I will discuss certain aspects mainly related to fluidized bed gasification of biomass as well as blends with coal. So, before starting discussion, we need to understand really what type of biomass resources are available, specifically in India. In literature, we can get several details about the resources as well as um, resource quantity. But really, we need to understand when we talk about the exploitation of these resources for specific applications, then we need to understand the available quantity of the biomass specifically for suitable for the particular application, as well as availability, time span availability of the particular biomass resource. And as biomass is a, comparatively low density resource, so available collection mechanism and feasibility also, these aspects we need to consider uh, primarily. So mainly, it is comparatively easy to utilize agro-industry waste because by default it will be available at some specific location. Then, to some extent, forest residues, because most of the biomass will be having comparatively moderate density. So this is also one of the attractive option. Then, when we talk about industrial waste, so at the particular effluent treatment facilities, we can get these type of waste material, as well as municipal solid waste and RDF also we can get at some specific location. So collection and all those aspects will not come in picture much. It will be comparatively feasible option. But when we talk about the agricultural residues or field residues, then important aspect is really collection of the those resources. So before going to install any facility, we need to understand the suitable technology as per the fuel properties. Number one, its commercial provenness and reliability also. Then economically, its attractiveness. And if it is indigenous, then it will be more feasible, we can say. So, to take any decision related to selection of gasifier and feasibility related aspects, systematic understanding related to solid fuel or say biomass or waste material is necessary mainly in relation with physicochemical characteristics of the particular fuel. So specifically for these type of fuels, generally proximate ultimate analysis (CB) we can get in the easily it is available. But other properties also are we can say rather more important, mainly density when we talk about biomass, because handling, transportation, as well as volumetric loading in the particular device. Then it dictates the gasifier capacity, feeder type, all these technical aspects, as well as density. It again prompts for the fluidization related aspects, mainly fluidization velocity or say type of fluidization, entrainment of fans. So these technical aspects also are dependent on the density. Then particle size distribution and shape, because handling of fibrous fuel is comparatively very difficult in the any type of gasifier. So type of gasifier, then specifically say for fluidized bed gasifier, if shape is fibrous nature, then fluidization is also becomes important aspect. In case of fixed bed gasifier, again particle size distribution as discussed in the earlier presentation. So it plays vital role mainly in view of bed permeability, simultaneously entrainment of fines also. So particle size distribution and shape is one of the important aspect in case of biomass. Then surface properties, mainly surface area, porosity, and gasification reactivity. These are important in view of mainly capacity of the gasifier or say residence time inside the gasifier, carbon conversion, then blending propensity. So, in view of suppose if we target blends of certain particular biomass along with coal or other type of biomass, then in that case mainly apart from the physical properties, reactivity should be within the more or in same range. So from basically from these all these properties, we can take decision mainly related to selection of the gasifier as well as the uh, blending related decisions with different combinations, as well as whether any pre-processing of the feedstock is required or not. Definitely crushing, screening, or sometimes drying also depending upon the moisture content. When we target its utilization in presently designed facilities, power plants, polarized power plants. In that case, sometimes torrefication, briquetting, pelletization, this type of processing will be required. So, on the basis of these physicochemical properties, we can systematically one can take the decision. We have done certain exercise mainly related to characterization using the facilities available at our institute. We have several facilities, analytical facilities as well as pilot scale, bench scale facilities are available for entire characterization of the solid fuels, whether it is biomass, coal, or derived products like ash, syngas. So on the using these facilities, we have done exercise. Again, we have one specifically dedicated instrument. It is a thermogrametric reactor. In this particular device, just I want to highlight this particular device because we can utilize this to get the idea about reactivity and kinetic data related uh, aspects with the fuel size and shape which directly we feed inside the gasifier. Means say if we are interested in characterization of reactivity or kinetic data for say lump size particle, having particle size 25 millimeter, whether it is biomass or coal or pet coke or any other waste material also. So directly we can feed that particular sample in this particular device, and we can get the reactivity, intrinsic reactivity, as well as the effects of pores and surface area also. So generally, whatever instruments are available in market like TGA and drop tube furnace, all those, from those instruments we can get intrinsic reactivity only. But with TGR, we can get the intrinsic reactivity added with all the effects related to surface area, surface properties, and particle size also. So directly we can feed lump sized, uh, then granular sized, as well as pulverized material, means micron level samples also, and we can get the reactivity related feedback for any thermochemical process related to gasification, combustion, or other processes also using any reactive or inert gases. So this device we have utilized, and we know the proximate ultimate analysis for different fuel. But interesting part is carbon conversion varies more or less in the same range for uh, variety of biomass resources and coal also. But interesting difference is VM part is more in case of biomass when we compare with mainly with coal. So it is the advantageous part when we talk about the slow phenomena, comparatively slower phenomena like gasification. So it becomes very easy to gasify biomass resources than coal. This is the added advantage. Another aspect is oxygen content is very high due to the oxygen containing functional groups in the biomass matrix. Apart from this reactivity point of view, when we see the reactivity of biomass, it is again attractive option. Surface area of directly biomass particles is comparatively on lower side. But once we create the pyrolysis of same particles, biomass particles, its surface area becomes very high, and that's why gasification phenomena uh, becomes faster in case of biomass. So certain these aspects we need to understand while selection or developing the particular gasifier. One more aspect is ash properties. Specifically in case of biomass, alkali content is more as compared with other sources, and this lowers the ash fusion temperature. Um, so we need to concentrate on the operating temperature of the particular type of gasifier, mainly say fluidized bed or fixed bed gasifier, because for biomass resources, uh, ash fusion temperature varies more or less in the range of 1100 to 1200 degrees Celsius. Whereas same for the coal is specifically for Indian coal, it is beyond 1350, even 1400 plus. So in case of biomass, we need to take more care to avoid the operational problems for biomass. So these are the certain important aspects uh, already we have discussed, so we can skip this particular slide. Now coming to the actual experimentation which we have conducted in our facility, we have conducted co-gasification as well as gasification of the particular biomass in individually also, and we observed CO hydrogen in the range of 15 to 22%. Carbon conversion was quite attractive. It was above 93%. Even for biomass, it was beyond 93 also. We have conducted all those experiments with the 20 kg per hour feed capacity gasifier in air blown mode, and now we have established higher capacity facility. Uh, it is having 1.5 TPD fuel feed rate capacity. With other utilities like oxygen generation facility, as well as it is a pressurized gasifier basically. Till date, we have operated this facility for coal, having ash content up to 42% from MCL area. And we have operated this facility in completely oxy-blown mode and got the syngas composition, CO in the range of 25%, hydrogen around 30%, and methane in the range of 3.5%. In this particular facility, carbon conversion was quite attractive. It is a highly concentrated syngas, we can say. Syngas yield was in the range of 1.4 to 1.7 nm³ per kg of fuel. And our next target is gasification of separately biomass resources, as well as blending with coal also, to improve the reactivity of blends. So that we can get the benefits for coal gasification also. So both these targets we have targeted. So our observations for this particular exercise is due to the low density fuels, mainly in the feeding section or handling section, feeding inside the gasifier using certain specific feeders suitable for biomass. Certain difficulties are there, but by systematic selection and design of the facility, we can overcome all those problems. Again, fibrous shape is difficult to fluidize, so that sometimes we need to modify the size of the particular biomass. We cannot use as it is. Mainly biomass like bagasse, which is having a highly fibrous nature, sawdust, as well as a rice husk or any type of husk we can handle directly inside the bubbling fluidized bed gasifier. But to some extent, bagasse we need to modify the size and shape by crushing. Again, due to density difference, when we go for co-gasification with coal, when we target utilization of the biomass as it is without any size reduction, say rice husk or any other husk with coal, then we need to establish the uniform fluidization with coal also. So accordingly, we need to crush the coal to desired size so that we can get the uniform fluidization for biomass and coal inside the gasifier. So that type of exercise is very much essential for blending of the biomass with coal. Then fortunately, low ash content reduces the ash removal rate and provides good residence time inside the fluidized bed, which is very much essential to get the attractive carbon conversion. So in case of biomass, this particular aspect is very much attractive, we can say. But as discussed earlier, due to the alkali content, so there is a little bit tendency of agglomeration, which prompts for the lower bed temperature to avoid the agglomeration, clinker formation, and blockage inside the bed. So these are the few our observations, and our next target, as discussed, is co-gasification of the biomass, individual gasification inside the bubbling fluidized bed. And for systematic understanding, particularly all the characteristics of the biomass, entire database is not available for all the biomass resources available in India. So we have also targeted gasification potential mapping of the available resources, biomass as well as waste resources in the India, so that we can be able to take the decisions for selection of gasifier, as well as uh, development of the different modules of the gasifier, right from feeding section, handling section, crushing, as well as gasifiers also. So, gasification potential mapping of the Indian biomass resource, as well as individually, as well as co-gasification of the various resources inside the fluidized bed gasifier, specifically bubbling fluidized bed gasifier, is also our next target. Then at the downstream, syngas cleaning, required syngas cleaning for particular application, for say value-added application like catalytic processes, chemicals, and fertilizer applications or methanol applications. Very stringent gas cleaning will be required even in case of biomass. So target is to establish the desired syngas cleaning to get the desired syngas purity and quality of the as per the required phenomena. Now coming to the what should be the strategy when we talk about the biomass utilization for different applications. Mainly, we feel that transportation should be avoided. As it is a very low density feedstock, so mainly transportation as much as possible it should be avoided because it will um, eh, it will apply huge transportation penalty, one can understand. Then next is the minimum pre-processing should be there. To some extent, yes, drying, crushing, screening, or drying if moisture content is on higher side, then this is we can say required pre-processing. But apart from that, uh, other pre-processing like say torrefication, briquetting, pelletization, all those should be avoided because in present scenario, people are using these particular pre-processing phenomena because particularly available facilities like say thermal power plants where biomass is getting blended with the coal and utilized for power generation. For that, either pyrolysis or briquetting is being utilized, but it adds the processing cost, and it basically becomes the two-stage process, means pre-processing at near the field and then main processing inside the actual facility, say gasification or combustion facility. So this should be avoided. Otherwise, availability of energy for torrefication briquetting becomes very unattractive, and definitely it adds the cost uh, with the particular feedstock. At particular processing unit, we can get um, available energy, waste energy, which we can utilize if any drying is required, say moisture content is on a higher side. We can utilize waste energy from the gasifier or combustor for drying purpose. But in the field, if we intend to drying and torrefication or briquetting type of uh, primary processing steps, then availability of energy will be from outside only, uh, which will be again a penalty, and this becomes the mainly feasibility comes in danger in this type of case. So process should be single stage process uh, with wide fuel flexibility. Wide variety of fuels can be handled in the particular type of say gasifier or combustor. And this should not have any capacity limitations. Certain type of gasifiers have capacity limitations also. So particular gasifier should be having wide fuel acceptability as well as it should not have any capacity limitations. This is the important we can say requirement. Then say for field biomass, one can go for decentralized uh, downdraft fixed bed gasification for locally to fulfill the energy requirements at particular area, say small scale power generation or certain thermal applications, but mainly with industry waste or byproducts from the say agro industry or any type of industry. Definitely, it should be industry integrated gasifier. Uh, Fluidized bed gasifier is attractive option for granular type of feed or even for RDF also. And for woody biomass, downdraft fixed bed gasifier can be become a attractive option. And product pattern also for this type of uh, resources, we can go for validated several products, including chemicals, fertilizer or methanol also, because quantity limitations will not be there. So we need to explore the suitability of particular type of gasifier, how particular resources should be utilized, what should be the scale based on the physicochemical properties, availabilities, location of the particular resource. Accordingly, we need to finalize the applications. As we have discussed, for field residues, it should be using, say, downdraft fixed bed gasifier. We can go for local power generation related activities to fulfill the local energy needs.
Right.
Uh,
Dr. Chavan, sorry to
yeah,
interrupt. I request you to please wrap up your presentation so that we
yeah,
can take some questions as well.
yes. This is the last slide, madam. Yeah. Again, for agro-industry waste, we can go for fluidized bed or fixed bed gasifier, because bagasse or rice husk or any type of husk, it will be easily available, and generated syngas also can be utilized for several value-added applications. So it can be industry integrated facility with the particular biomass resource industry. Again, forest residue and waste, it can be treated separately in the flat bed or fixed bed gasifier, or for forest residues, biochar is also attractive option, as well as one can go for value-added products like which we have discussed above, and same is applicable for RDF as well as industrial waste also. So this is the all about the uh, our experience and observations in the um, program which we are executing at our institute. Yeah. Thank you, madam.
A big thank you to all our speakers for their insightful presentations. Thank you so much for giving us these presentations. Now we have a few questions. So I'm going to hand over the mic to Mr. Shakti Kumar Pandey, who has the first question that he wants to pose.
Yeah. Am I audible?
Yes, sir, you can turn on your camera as well. We can hear you
Okay.
clearly.
Okay, but I want to turn the camera also.
Yeah, you
Okay,
can
fine.
turn it
Yeah,
on, sir.
yeah, yeah, yeah. Yeah, this question goes to Mr. Varun Kumarji. It was definitely a very good presentation. Mr. Varun Kumar, we have got the, as we know, the time, temperature, turbulence, and active sites. These are the four factors that determine the performance of a gasifier for the different. In case of the entrained and the fluidized based gasifier, which one gives the more reactive sites for the reaction to uh, syngas?
So, sir, I would like to answer your question slightly differently.
Right.
You see, as I said in the presentation, my understanding is all the gasifiers are good gasifiers. I think Dr. Prakash can also say all are good. They are conversion equipments. They can convert a solid fuel into a gaseous fuel. Now, the problem with this statement is that we should know what this conversion equipment can convert. What is the input that it can take? For example, as I explained that fixed bed systems, updraft systems can take high ash fusion temperature hard coals. As the CFD gasifiers are more suitable for low ash, light, low fusion temperature coals. Entrailed bed are suitable for coals which ash can flow. Now the problem is that for finding the right raw material for an entrailed bed, you need to do the complete analysis that how will the ash behave when subjected to such pressures and such temperatures. So there is no answer which is good, which is bad. Answer is which is suitable. You have to find out and analyze for your raw material, whatever raw material you have, what is the most suitable technology.
Right, because that's our ash content is in order from 35% generally, as against.
Sir, I don't know. It's in the industry. Most people who have never dealt with coal, everybody comes up with this statement. Our coal, India has all types of coal, starting from coals with very low ash to starting to coals of very high ash. Now we need to find out which coals can be gasified, and I have been talking to coal ministry and most of the representatives that why are we trying to do something which is not doable? Why don't we try and find coals and collieries which have medium ash, 25 to 35 ash and medium VM, and try and gasify that?
Now, if we
Why are
take
we
the
rewriting the whole physics and chemistry of the gasification industry?
right, right. So let us forget about the Raniganj coal and the Rewa coal. If you call the other type of
I'm
coal,
saying, I'm saying, let's leave the very good coals also, and let's leave the very bad coals also in terms of ash content and CV, and let's focus on the middle range.
right,
Even
right. Let's
that,
put this way. Let us
even
put
that
this way.
coal we have more than 1 billion. Okay, even that coal we can gasify, and we are. I mean, I have no words to say what we are doing. We are just discussing and debating, and nobody says that okay, this is the coal, this is available, this is the most suitable. These two collieries are reserved or specified for coal gasification. Right? That's not happening in our country.
Let us come to the bituminous coal mostly found in India. So, because I am asking these questions that the Talcher plant, fertilizer plant, failed this gasification on account of the technology mismatch. And the main reason behind the failure was reported to be the high ash content. China has developed, which has only 25% ash content, we have about 35%, as it was reported to be. So, in this context, my question was that for the bituminous coal found in India, which contains, if I am right, around 35%, which type of the gasifier is the most suitable? That is my question.
Sir, for Indian coals, up to 35% ash, CFD, according to me, is a better technology. But I will caveat my statement with the fact that different collieries and different regions within CCL umbrella have different characteristics of density and ash fusion temperature and caking index and various other components like plasticity of the coal, which need to be measured to say the appropriation of the coal for a particular technology.
Okay, thank you, Mr. Kumar. Thank you very much.
Thank you. Thank you.
So particularly for culture coal, government has already planned a culture fertilizer project where they have planned utilization of high ash coal along with pet coke. So blends will be prepared to bring down the ash content below acceptable limit, and uh, it is going to be gasified inside the Entrained gasifier also. Apart from that, already GSPL has tried. I think if Tiwari sir is there, he can comment more. But they have also tried for MCL coal. And definitely, blends of low ash, high ash coal will work inside the entrant flow gasifier as well as fixed bed gasifier. And in the fluidized bed gasifier, it can be gasified without any blending also, without any blending or washing. But only thing is readily available or proven technologies are not available under fluidized bed. But we have tested in our fluidized bed facilities up to 48% ash containing coal. So it can be gasified without any operational issues in fluidized bed gasifier at least.
Just to add to what Dr. Saab has said, the plant which I mentioned in China running for the alumina calciner, The coal which they are using is bituminous, not anthracite, and it has around 27-28% ash. So it is possible, like Dr. Prakash is saying, it is possible that Indian coal up to 35% ash can easily be gasified in the CFD gasifiers, provided they are not detrimental to other aspects at that temperature. Right.
I'd like to add here something a little bit to the ash content related to the coal part. See, what our experience has been for CFBC gasifiers and the entrained gasifiers. Entrained is basically introduced, this technology is introduced to utilize high ash coal, which CFBC gasifier is, as of now, not capable to utilize. It's absolutely clear. Our partners have tried using high ash coal. As Varunji said, up to 25% ash is possible for CFBC gasifiers. But beyond that, you need to change your technology to entrained gasification. Entrained gasification can take ash content up to 40-45%, which is a beautiful technology for India. And the best part about this entrained gasification is that the calorific value of the gas is double that of normal gasifiers. Like if we talk about fixed bed gasification, we talk about CFDC. Entrained gasification has CV around 2600 kcal. This is because you're able to use oxygen 99.99% these entrained gasifiers.
All right. We have Mr. A.N. Tiwari also with us. Mr. Tiwari, please go ahead and ask your question. You can start your
Yeah,
camera as well.
thank you. First of all, I don't agree, Rahul, that entrained bed calorific value is double than of fixed bed gasifier. How can it be?
So there is no nitrogen in the gas. I'll share the gas
No,
composition
no,
with you.
no gasifier is having nitrogen, sir, other than the gasifiers running on atmospheric and producer gas plants. So
So
let us not discuss that thing, because if you see the calorific value of entrained bed, they will CO and hydrogen both will be roughly 85. So they are 26, 2700 is the calorific value there, and you will have the same value in the fixed bed also, because fixed bed have methane of almost 13%, so which increases the calorific value. So if you
so
talk the calorific value is high in the fixed bed. Anyway, yeah, please.
I am talking about gasification not before the steam shift, where you increase the hydrogen.
I'm not talking steam shift, sir. I'm talking gasifier. I'm not talking steam shift. I'm talking gasifier outlet, raw gas.
Raw gas calorific value, you said how much was that?
It's around 2700, 2800.
That is what I'm saying. That's exactly what I said. In train flow
The,
gasifier, we can
the
get.
fixed bed also, the fixed bed also have that.
So you must be doing some oxygen enrichment in that, sir.
Oxygen enrichment, how can you do the oxygen enrichment? There is nothing like oxygen enrichment. Gasifiers are partial oxidation. You cannot increase the oxygen. If oxygen goes
Without
into
So
the
trying,
system,
basically,
it's
explode.
not 100% oxygen. Their
It's
gasifier in Nakul is using
gasifiers are oxygen only, 100% oxygen only.
Obviously,
In
in
the
that case, then you can get that CV, no, sir? Because
that's what. So you, when
your
you told the
gasifying
fixed bed will.
your gasifying agent is oxygen in place of air. So there
So
is no
Rahul, that's
nitrogen
what.
in your
You
final product.
sir, please don't compare producer gas with the syngas. We are talking when the syngas producer plant will never operate with the oxygens. So let us not confuse with those things. Regarding blending of the coal, when you are blending the coal, you are bringing the ash down only theoretically. Practically, it is not possible because it's not a homogeneous mixture. If you are using all other gasifiers, they will be two different material, and gasifier behavior will be totally different. In trend bed, it may not have that much impact because it's you are using almost 200 micron, and in 15 seconds it will burn and go. So in trend bed, it will not have that much impact, but fluidized bed and fixed bed blending is not the solution. JSPL was blending because we were using imported coal for the high FC, not for the purpose of ash reduction.
Right,
the
Mr.
coal
Tiwari,
imported.
You have any specific question to one of the
Other
speakers?
specific question, Varun, you were telling that we can mix the lignite. Lignite is a solution. Lignite has almost 50% of the moisture, and that much moisture goes in the gasifier means that much energy is consumed. So your specific consumption will increase. So how you say that lignite is a solution for reducing the ash, because you are putting lot of water and water has to go as a water vapor. Lot of energy is consumed, and for that coal has to burn in that.
Yes, Tiwariji, but when you talk to Naval Lignite, they are sitting on those deposits doing nothing. Okay, so whatever in my presentation I have presented, and I am a businessman, I am not a scientist. So whenever I say something, I have a commercial angle to the same suggestion always linked behind it. So
No, that's fine, sir.
when I say we can use lignite, there is a commercial aspect of lignite cost being zero, right? Why zero? Because we are not able to use it. For example, in Rajasthan, there is no practical industrial use to whatever deposits we have. So, when we are saying there is the economic carryover, yes, I understand. I cannot deny any technical point which you are raising, but please add the commercial side to whatever I'm saying. You can get much better value even with wastage of resources of trying evaporating water and getting it back. I've done the maths. We can share.
Yeah, that's okay. All the maths on the papers are working good.
Sir, for
Practically,
Naval
this is
Lignite, NLC has already published expression of interest, and they have plans for gasification based methanol.
no. Everybody is planning. Chavan sahab, everybody is planning. Who will come? Question is that last 16 years I'm hearing that.
And
So I'll
lignite
contact
can
you.
be lignite,
And
since it is
Varun,
lowest.
Varun
Tiwariji,
will.
Tiwariji,
Yeah,
I'm also listening this for a very long time, but probably from last 3 or 4 years, I am happy that developments are happening in India and there is some policy making is happening. Am I right, Varunji?
At least we
you
are
are.
moving. At least we have a forum. I really appreciate that. At least we are being called by Ministry of Coal, Ministry of Steel, Niti Aayog. At least me, Rahul. We have been talking to people, and at least somebody is listening.
Yeah.
So yeah. So Tiwari is saying yes, frustration is there in the industry, but there is a positive side also. So life is like this. I think we have to be.
Right.
Let's be optimistic. And
We have to be optimistic.
last 2 3 years, I am being called by Niti Aayog. Last month, I was there with the steel minister. JSPL was there. There were other steel companies who were there, part of the entire consortium. I was there, part with Saraswat to Bhale's pilot project inauguration. So now we can see that there is some development happening at least. In the earlier
Ashwin,
governments and earlier things, we
I'd
were
like
not seeing anything.
Ashwin, I'd like to butt in here. Actually, the problem is, you know what happens? There are certain players in the gasification industry which are very novice players who have just, because of their enormous business background, they have entered into the gasification industry and without much knowledge. And let me tell you, this CFBC, we've been struggling with CFBC and Entrained Gasification for roughly around 2 years. We tried to convince people to set up these gasifiers, and we were at the threshold of setting up one of these CFBC gasifiers. But because of one of such industry, giant, this whole project, it got, I don't want to name anybody, but the whole project got shelved off. And I mean, we were good to do this project at all those technicalities, meet all the requirements of the client, and the technology provider, they backed off. Who got the order, they backed off. They could not execute the project, and this prevented us to get this technology into India. Otherwise, we would have given this technology to India. It's a wonderful, beautiful technology. So,
Right. We hope, Mr. George, that people will now be more open and more progressive towards what possibilities exist with technology. We have another question coming in from Pankaj. Please go ahead, Aditya. Please tell us who do you want to ask the question to? Aditya, if you can hear us, please start your camera and go ahead and ask a question. Yes, please go ahead and
Hello,
ask your question.
good evening, all of you. And as per the meeting scenario and the topic based on the gasification and waste management technologies, basically there is the issue of the communication, and I think there is the gap of policy management in India, basically in the field of waste management, because generally we are working on the papers, most of the work on papers. We are not managing the all of the waste entire the you can take just a uh, municipal corporation. Basically all of the municipal corporation doesn't follow the waste management system.
Right.
if
But
they if they don't
Aditya,
follow
do
the
you
waste
have a
management system, then
specific
how could we
Aditya,
can
do you
implement
have
the
a
technology?
specific question to any of the speakers on their
I
presentations, the
have
presentations
I
about the
have a question.
technologies?
I have a question that in this meeting we are able to set up the policy which is easily available for the municipal corporation and easy to implement. Is there any scope in this meeting?
Dr. Chavan,
Uh,
would you like to take that?
Yeah, basically, when we talk about municipal solid waste or RDF, refuse derived fuel, gasification point of view, technology related challenges are, we can say, we can overcome. Uh, Feasibility, when we talk about the feasibility, pre-processing is the important aspect because several segregation of other foreign materials, including glass, metal, plastics. So all those several steps comes in picture, and it requires lot of infrastructure as well as operating cost. That is the part. Otherwise, once we generate the refuse derived fuel, it can be handled in the fluidized bed gasifier.
All right. I would like to thank all our speakers for taking the time out and giving us the presentations on the technologies that are upcoming, innovative technologies. And I hope all of these will be welcomed with open arms. And we'll have more gasification units coming up, and different technologies suitable for Indian conditions will be adopted very soon. Thank you all for joining us, and thank you for answering so many questions that you have taken up. We're completely out of time. We would have liked to take more questions, but we have one more day, so we can take up all these questions. We come to the end of day one of Gasification India and Waste to Energy Conference. We hope you've enjoyed the sessions and picked up valuable insights for your company's operations to optimize clean energy usage and reduce waste generation. Please join us again tomorrow at 10 a.m. sharp for more knowledge sharing through panel discussions and presentation sessions. Thank you and see you soon.
Thank you,
Thank
everybody.
you.
Thank you.
Thank you.